It says an amusement park safety inspector plans to leave his home in Cincinnati, Ohio to inspect roller coasters at parks in the following cities. It actually could just be inspect roller coasters in the one park. It could be the Scream Machine, then the, I don't know. I haven't been to a park in a while. But it doesn't even have to be cities. It could be just roller coasters are the vertices. Okay, so we've got 1, 2, 3, 4, 5. So I always count the vertices first. Then I put it on like a circle-ish. Put them like that. And you can say Atlanta, there's Cincinnati, to Cleveland, to Myrtle Beach, and to Williamsburg. I used to go to Busch Gardens a lot in Williamsburg as a kid. That was fun. Okay, so we need to create a complete graph. Now we put the weights on. What is the cost of flights? Like I said, I just look at one. I focus on either the top triangle or the bottom one. And I just do every number. So Cincinnati to Atlanta is 97. Cleveland to Atlanta is 110. Myrtle Beach to Atlanta is 104. Williamsburg to Atlanta is 395. Okay, Cleveland to Cincinnati, 35. Myrtle Beach to Cincinnati is 355. Williamsburg to Cincinnati is 281. And Myrtle Beach to Cleveland is 400. Williamsburg to Cleveland is 390. And then Myrtle Beach to Williamsburg is 225. Okay, so that's the complete weighted graph. Yours could be different. You could have the vertices labeled in different ways, but they still should have the same associated weights. Okay, part B is use the nearest neighbor method to approximate the optimal route for the inspector to go to each city and return to Cincinnati. Give the cost of the route found. And then it says to randomly select another route from Cincinnati to other cities. So we can also reinforce that it might not be the optimal solution. But with the nearest neighbor method, we will all get the same answer. So we're starting in Cincinnati. So from Cincinnati, we have, let's see, we can go to Atlanta, Williamsburg, Myrtle Beach, or Cleveland. So you want to compare the costs. So we've got 97, 281, 355, or 35. So which one are we going to pick? Which one is the cheapest?
35.
Yes. So it's 35 bucks. So now that we go to Cleveland, now we have, let's see, we can go to Atlanta, Williamsburg, or Myrtle Beach. So our options are 110, 390, or 400. What are we going to pick?
110, so Atlanta.
10, so we're going to Atlanta. Right, so we're just picking the of the choices in front of us, we're just picking the cheapest one. Okay, so now from Atlanta, we have 104 versus 395. Which one do we pick? 104.
104, so we go to Maryland then.
Myrtle Beach.
Myrtle Beach, sorry, Myrtle.
And now we don't have a choice. Now we have to go to Williamsburg. And sometimes this is the most expensive one. That's why it ends up being the not optimal. So this is going to be $225, which wasn't too expensive. And then we have to return home to say to our spouses or our loved ones, $225. Go back to Cincinnati. All right, so what's the cost of this route? And then I want you to pick any other random one. $7.55. Now I'm going to choose a random one. Let me know if you chose a random one and got something less than $7.55, please. So Cincinnati to Atlanta. Go to Myrtle Beach. Cincinnati, Atlanta, and Myrtle Beach. And then I'm going to go to Williamsburg. So Cincinnati 97, Atlanta to Myrtle Beach, that's 104. Then 225. And then we have to go to Cleveland. I think we're mostly going to get higher costs. And then we're going to use the 35. So the one I chose I have a feeling it's going to be higher. So it's kind of confirming that we're getting a near optimal solution, or maybe the optimal. Yeah, I'm getting 851.